So I have come back to recording after a few days, and the camera and the mic are acting funny. So I hope the recording goes well. Okay, so we just concluded the executive summary with descriptions of all the trends, regional, local, and the report provides some amazing figures that I'm going to use. I think in the previous podcast I ended by saying we will look at some amazing papers, but actually what I meant was we'll look at some amazing figures, which is what we are looking at here, and there are a lot of them, so we may have a couple of podcasts discussing these things. Again, executive summary. So the JJS rainfall has increased in majority of the country, but decreased over the Indo-Gangetic Plains, northeastern India, and Indian Himalayan regions in the last decade. So always pay attention to the period over which they're talking about the trends. Okay, so this is changes in JJS rainfall in the last decade, so 2012 to 2022, compared to the climatic baseline, which is computed over 1982 to 2011. So it's a kind of a decadal trend. So you have negative changes here, Himalayan foothills, northeast, and you have to be careful because India doesn't have data over Pakistan, Nepal, Bhutan, Bangladesh, so this can be kind of confusing, and we focus very much on the data we have, of course, but it doesn't change the fact that we have some seriously positive trends here and or positive changes here. So these are the numbers here, greater than percentage change of greater than 30% and less than minus 30% when you have the dark red colors. Let's say this is mostly in the 20 to 30% deficit or decrease over this decade. And here I have been involved in some work showing that the Middle East warming, Mediterranean warming is shifting the winds over here and creating heavy rains, excess rains, extreme rains over northwestern India into Pakistan. Pakistan has had floods every year since 2010, as we said already. And there are other ideas. People argue that it's because of the Hadley cell expanding and so on and so forth. But leaving that aside, you can see that statistically significant trends in JJS rainfall over 40 years continue, 40 years continuous time series. So the trend over the longer period, the entire study period 82 to 2022, looks different, but still this trend stands out. So this is a decadal change as well as a 40-year trend, but you can see large other parts largely lose the significance of the trends, but you have this strange pattern here of increasing rainfall trends in percentages over the last 40 years, and here. And remember, this is only JJS rainfall. This region also gets a lot of OND rainfall, which we will look at. Both the western and eastern coasts of India have seen an increase in OND rainfall in the last decade. So now we are looking at decadal change in OND. There is post-monsoon increase here as well. So this region is not very particularly influenced by OND, but when you do OND rainfall, you get excess here and deficits here. Basically that means post-monsoon, but this is the typical northeast monsoon region, OND rain region, and that has increased here but has decreased here. The Himalayan foothills has decreased in both seasons, and there are some patchiness, and you have some increase over here as well. And how they are related to wind shifts and the Arabian Sea warming, and the fact that the JJS rainfall itself may be expanding or withdrawal may be delayed and so on, that I mentioned in the last podcast. Okay, so very patchy looking thing. And here again, statistically significant trends in OND rainfall. You see that a lot of these regions just disappear except one here, which can be more related to western disturbances and so on, which begin to occur in the fall winter seasons. And you still have this patch remaining, and of course this holds up and this holds up. These are northeast monsoon periods. So why it's high here and some positives here, but this region gets no trend and this does, all has to be understood in terms of the dynamic changes, so circulation changes, wind changes, and thermodynamic changes which can be related to coastal warming, ocean warming, and moisture supply, and so on. So those are very general words, but you should always remember that rainfall is a complicated process, a combination of dynamic and thermodynamic changes, which are always interesting to deconvolve. 24% of the tehsils have witnessed both a high number of deficient as well as excessive rainfall years in the last 4 decades. So you have deficient years and excessive years. So you can see large parts of this region here and these regions here. Many of these are semi-arid. If you go to northeastern Karnataka and eastern Maharashtra, you get into semi-arid regions, whereas coastal regions are very wet, of course. So you can see that there is increased variability in time, and there's been papers before that looked at spatial variability and argued that spatial variability has increased, and people have argued that number of extremes have increased. So it all depends on how you average. So you can see that if you average over the core monsoon zone, you may get a very different answer compared to when you look at spatial maps of the trends. Okay, so just remember that always. So this means there is a mix of deficient years and excessive years, especially in some regions like the northwest, central, west, northwest here. So, and peninsular India on the eastern side of the Western Ghats, which also got some rain here during OND as well as during JJAS. Okay, so this is just the number of deficient and excessive years, but if you look at the total number of tehsils that witnessed an overall decrease in JJS rainfall, 68% of tehsils consistently experienced reduced rainfall in all JJS months, while 87% showed a decline during June and July. So as we always say, there is a seasonal total which is decreasing, JJS, that we looked at in some places. Then there is a distribution of rainfall. Onset happens, June gets, let's say, about 15 to 20% of the seasonal total. July, August are the peak rainy seasons in most places, and then September is the withdrawal. So onset has changed, withdrawal has changed, distribution of rain. So length of rainy season has changed, but distribution of rain in terms of number of rainy days or excess and deficient years. So you can see change in June rainfall in the last decade compared to the baseline. Very heavy rains here, which remains consistent in all statistics. This region also always comes up as positive. This was seasonally deficient, but also deficient in June, but not so deficient in July. This one remains excess in June and July. These are important because farming tends to depend very heavily on distribution of rainfall, crop calendar, and so on. So these are statistically significant changes all for all the 40 years. So this is a significant trend, whether you just look at last decade or 40-year trend. Of course, you have to be careful because the 40-year trend may be dominated by what happened in the last year. So you have to also look at probably the trend over the previous 30 years, 1982 to 2011, if you want it to be completely open about how things are changing on decade to decade basis. They are just looking at the last decade and the 40-year trends, which you have to be careful. That's not the complete story. So changes in July rainfall in the last decade and the 40-year trends. This disappears now in July trends mostly, but this remains and some other patterns emerge, and this also changes. So here July, this past decade has changed, but over the long term the trend is not so large scale. There are patchy changes, but they are statistically significant. So it's always important to understand what is driving such local trends. This is generally a very big challenge. How do you take 40-year trends and still produce such patchiness. The patch here, patch here, patch here, patch here. This is a larger patch, but you can still see patches. How do you maintain trends for such a long time in such small regions? What is the dynamics of creating local excess rain while the regions around are not showing any excess rain? What is such a local process that can go on year after year? Of course, this is part of the core monsoon zone, and this is also argued to be the corridor in which the extremes are stuck for more than a century, and there are topographic features here and so on. So you have to understand all those things. If you look at the same thing now in August rainfall, again August shows last decade deficits here and excess here. This region lights up here, and this lights up even in the 40-year trend. So this decreases, this almost completely disappears. So there is a change in the last decade, but in a 40-year trend that's not so significant. This also disappears, mostly the last decade change, but this remains. So August rain has trended up. Over here, overall Kerala has seen decreasing rainfall, but you can see that July has not had a significant trend. August has increased, which means June, if you look at June, it has decreased or has no trend. So these are interesting features, and this is statistics. You have to then find the dynamics behind the evolution of the monsoon through the season and why and how that is changing. What is the role of the ocean? What is the role of the circulation changes? What is the role of moisture supply? And so on and so forth. This is changes in September. Now you get another pattern here, but this region remains, and you get deficit here. In the 40-year trend, again, this disappears, so it's mostly the last decade, but unfortunately they haven't looked at the previous decades. But you can see that this September trend remains. In the long term, maybe it has in fact decreased in the last decade compared to the 40-year trend, but this almost completely disappears. I'm just saying these in words because these are interesting features that you need to go back and look at the report in detail to understand what's happening. This is 64% of the Indian tehsils that saw an increase in the frequency of heavy rainfall days during JJAS. So the last decade change, so there are some decreases in this band where we have seen rainfall decreases overall, and of course rainfall here is increasing, which means it comes as increased number of heavy rainfall. You always look for duration, intensity and frequency of rainfall events, active break periods. There are studies that have shown that break period activity has increased, active period intensity of rainfall has increased. But the main point I would take is that all the interannual variability and global warming, decadal variability, everything tends to project on active period mechanisms. So that's very important to understand overall. So if you look at the significant changes over the 40 years, this seems to be mostly last decadal decrease, but there is also a longer term trend, but these have a longer term trend that persist for the 40 years. Okay, so you have to find some consistency between all these papers and this particular report, which is looking at it in a slightly different way, splicing it into small scales and also looking at each month. So it gives you new information, but it has to be consistent with the old information. For example, if there is an argument that extremes are stuck in this corridor for a whole century, but it doesn't show up here, it shows up here but not in the trend, does that indicate that in fact there is no trend in the location, that it's waxing and waning in this corridor, but there are new places that jump up that are not in the corridor? Okay, changes in the frequency of very heavy rainfall days in the last decade, and this is the trend. So what's the difference? This one is just the number of tehsils that we are talking about, so number of days per year, whereas here you are looking at number of days per year in terms of change in frequency. So this is the heavy rainfall during JJAS. What am I missing? A very heavy rainfall days in the last decade compared to baseline. Changes frequency. Did they miss the OND? Yeah, it should be OND there. Okay, so just be careful. They haven't mentioned it, so I'll leave it here. How many slides do I have? Maybe I can just wrap it up. Oh no, there's many more slides. This is already 15 minutes, so let's stop it there, and you can go back and look at the report to clarify this. Can I look at it again and say what it is? So here 64% of Indian tehsils saw an increase in the frequency of heavy rainfall days during JJS. That's fine. This is showing changes in the frequency of heavy rainfall days in the last decade, and this is the 40-year trend. Okay, so statistically significant changes in the frequency of heavy rainfall days. This is changes in the frequency of yeah, I cut off the title. This should be OND. Okay, so just go back and make sure. Okay, so we'll come back and continue the discussion, and I'll also look that up to make sure that I clarify it in the next podcast. Okay. Okay, so I'm just restarting this podcast because I was being stupid. There's nothing wrong with the report. So the first two maps are last decade's change and 40-year trend in heavy rainfall days during JJAS. 64% of the Indian tehsils saw an increase in the frequency of heavy rainfall days during JJAS, whereas this is very heavy rainfall, so changes in the frequency of very heavy rainfall, and this is the 40-year trend. So you can see there have been places, now the corridor of extremes shows up. I have discussed this corridor elsewhere. It's a nice little paper by Udit Bhatia and his students, and I'm a co-author. It says that for a century heavy rainfall events have stuck in this corridor. No explanation yet, but you can see very heavy rainfall has again increased over many regions. But if you look at 40-year increased in the last decade, if you take the trend, then there are very few places which over 40 years have seen very heavy rainfalls trending up in terms of number of days per year. Stupid of me, sorry about that, but I can always correct it, right? So here we go. Let's leave it here.